A carve turn is a skiing term, used to refer to a turning technique in which the ski shifts to one side or the other on its edges. When edged, the side cut geometry causes the ski to bend into an arc, and the ski naturally follows this arc shape to produce a turning motion. The carve is very efficient and allows the skier to maintain the speed. Unlike older techniques like the stem Christie parallel turns based on stemming, which can create significant drag, starting a carve turn requires the ski to be rotated onto its edge, which can be accomplished through small movements of the hips and knees. This motion is very easy to apply to both skis at the same time, and carving is a naturally parallel technique. Carving turns are generally much smoother and longer than stemming, and keep the skis along the direction of travel as opposed to angled across it. Both of these reasons means that carve turns require far less effort than stemming for the same given amount of control over the descent. However, the technique is not simple to learn, at least before the introduction of shaped skis in the 1990s. Since that time, it has become increasingly common to teach carving as a form of parallel skiing, as opposed to the classic parallel technique. Modern downhill technique is generally a combination of carving and skidding, varying the ratio between the two when rapid control over the turn speed is required. However, pure carving and pure stemming are used in certain circumstances. Pure carving is a useful technique on slopes of moderate steepness and smooth snow. Groomer carving is widespread and there are skis dedicated to this style. Likewise, competitive mogul skiing remains an almost pure parallel Christie technique, although the turn initiation is aided by the moguls themselves. History. Shaped skis, also called parabolic skis, make carve turns possible at low speeds and with short turn radius. They were first developed in 1988 by Jure Franco at the Slovenian ski company Elan. With his colleague Pavel Skofic, they organized a project dubbed Sidecut Extreme and set out to build prototypes. The experiment proved immediately successful and the Elan factory ski team began winning almost every race they entered. In the US, ski instructors found that students could easily make parallel turns that would otherwise take considerable practice and training. The company put the ski on the market in 1993 as the Elan SCX. Shaped skis were almost unheard of until the early 1990s, when skiers began noticing certain advantages to the deeper side cuts of snowboards, especially alpine snowboards, and the carving ability that this shape offered over the traditionally shaped ski. Skis of this new shape have since become the common, and in many areas, the only kind of recreational ski available. The idea of shaped skis was formed by approaching the occurrence of skidding from a different perspective. Two basic assumptions were applied: that the ski would bend when edged only to the point where the ski center came in contact with snow surface. The ski would not skid only when all the points of the edge of the ski traveled through the same point on the snow surface. If radius of a turn is chosen together with edge angle, calculation of side cut was relatively easy. The final result was radical parabolic side cut. Dynamics. When attempting a carve turn, a skier is skiing in dynamic equilibrium, so, to balance the centripetal force, the skier must bring the center of mass to the inside of the turn radius. This is very much like a cyclist leaning to the inside of a turn to avoid being thrown off of his or her bicycle. Beginners to the sport are often hesitant to angulate into these turns, as they feel that such an action will cause them to fall. Ski instructors therefore teach new skiers to overcome this hesitation. The ski is made with the side cut radius. This is the radius of a circle that would fit into the shape of the edge of the ski if viewed in plan view. This is approximately the maximum radius of turn that can be cleanly carved. Expertly used skis are capable of carving clean circular arc segments whose approximate minimum radius is proportional to the cosine of the angle of tilt multiplied by the side cut radius. Path carving typically involves the skier making a series of Cs, or half circles, down the hill. Skidding turns, on the other hand, would rather follow a Z-shaped path. Some instructors teach their students to think of these half circles as a clock. For example, the most extreme left portion of a turn would be at 9 o'clock and the extreme right is 3 o'clock. The turns are accomplished by utilizing a rolling of both skis from edge to edge. Speed. Recreational skiing is usually done at speeds in range between 5 meters per second and 15 meters per second with average turn radius of less than 15 meters. Accordingly, side cuts of modern recreational skis are calculated for turn radius of approximately 7 to 15 meters. Unlike a skidding turn, which primarily uses the skidding effect to reduce speed, a carved turn does not lose any speed because there is no braking action in the turns. Rather, the reduction of the average path slope angle resulting from the carved skier's S-shaped path down the slope, as opposed to a path straight down, reduces the skier's speed. The carved skier wishing to go slower must wait a little longer before initiating the next C-turn, making the C longer. This will lead the skier to ski more across the slope, reducing the average path slope angle. Snowboarding. A carved turn is distinguishable by its subsequent pencil-lined mark left in the snow. This indicates that only the edge of the board made contact with the snow and no skidding took place during the turn. The rider is using pressure, twist and tilt to get only the side of the board into the snow, then engaging the side cut edge which determines the carved turn shape. This type of turn causes the board to bend and store a large amount of potential energy during the turn, allowing this potential energy to be released and then used to propel the boarder into the next turn. The act requires the snowboarding skills of twist, tilt, and pressure to engage the edge into the snow and start the turn. No pivoting should be involved while the edge of the board is engaged with the snow, as it will cause skidding, or the edge to release from the snow.